I know what you're thinking. Really, really cool steering wheel. I actually invented this myself. Take a look. Making the steering wheel bigger makes it easier to turn the wheel. The bigger the wheel, the easier it is to turn because of torque.
Twerk?
No, not twerk. Torque. Torque. Force in a circle. Force rotating. That's torque. Torque is like force, but force going in a circle. It's force times the radius of that circle. That's how you calculate torque. And it's everywhere. It's not just in cars. Mechanical engineers need torque to make gears. The bigger the gear, the bigger the torque. You need torque to open up a soda bottle or a jar lid. It's all over the place. But what is torque? I know just the person to ask. Here I have Rachel. She was a physics all-star when she was in high school that did pre-AP physics and AP physics. Rachel, why don't you tell the viewers what torque is?
Twerk?
No.
Like a dance.
No, not twerk. Torque. Tell them what torque is.
Torque. Okay. Torque is force times radius. But physics isn't really that important. You see, I'm an English teacher, and English is so much more important than physics. You're never going to use physics again in your life. I mean, English, you're going to use...
What I'm trying to say is, torque is force that goes in a circle. Forget everything I just said and remember that torque is force that goes in a circle. Think about a wrench, for example. If force and radius are perpendicular to each other, that is, there's a right angle going between them, torque is force times radius, just like the equation below. Force times radius will give you torque. Look at the image of the wrench. Which hand will have an easier time rotating the wrench, A or B? If you said B, then you're correct. Torque is force times radius. So, if the radius is very large, and you're trying to get the same torque, then force will be very small. The bigger the radius, the smaller the force to have the same torque.
Well, there you have it. Thank you so much, Rachel. We all learned a lot from that.
Sure thing, Mr. Poe. It was my pleasure. By the way, you're a great teacher. You look great in that shirt. Your kids are lucky to have you, and you should probably run for president one day.
Not long ago, I asked one of my students, hey, can you please prop open my door for me? And she couldn't do it. She tried a few times. She said, Mr. Poe, it's not working. Here's what she did. She got the door stop. She put it in the center. And of course, it's not strong enough to keep the door open. I told her, don't put the door stop near the center. Put it towards the outside. The further outside, the bigger the radius. The bigger the radius, the greater the torque. The same thing works for opening the door. If you push towards the inside, you're going to look like a total weakling. You can't open it. You don't have enough torque. If you're opening a door, push towards the outside. Requires less force to have more torque.
Imagine there are three brothers sitting on a seesaw, two on the left and one on the right. Now the brothers on the left have more torque, but how much more torque do they have? Let's say the brothers are each sitting 2 meters away from the center and they weigh 600 newtons each. Let's calculate the torque. Remember, torque is usually going to be force times radius. So just multiply their force times how far away they are from the center. The brothers on the left provide a torque of 2,400 newton meters. The brother on the right has half that, 1,200 newton meters. Doesn't that make sense? He has half the force, and so he has half the torque. Now let's say that the brothers want to actually balance the seesaw. How far away would the brother on the right have to move backwards to balance the seesaw? We'll just use the same equation as before. We want both of them to have the same torque, 2,400 newton meters. For that to happen, the brother on the right has to move back 2 additional meters, so that he's twice as far back as the brothers on the left.
$998, $999, 1,000. Oh, deep burn. Don't know if you heard me counting. I did 1,000. I am extremely strong. Humongous arms. Speaking of my gigantic guns, this gun is 0.3 meters long. 0.3 meters. And that weight is 50 newtons. Can you calculate the torque? Torque is force times radius. It's going to be those 50 newtons times the 0.3 meters. So the torque would be 15 newton meters. I hope that you learned something today. Torque's really important, and it's everywhere. Torque's the reason that the little levers on the nutcrackers are so long. You need torque to bike, to turn the pedals, and to rotate your fishing lure on your fishing pole. It's really important. Go tell your friends, tell your family, tell your wives, shout it from the mountains and the rooftops. You be the torque of the town.
That was really lame.
I'll edit that out later.